We're now going to look at rolling dice. This would be an independent probability. And the reason that it's independent is when I roll one die, it doesn't affect the roll of the second die. And it doesn't affect, in this case, the roll of the third die. So when we're looking at this, this is going to be independent probabilities. That means our denominators are not going to change. With the cards, it was dependent. Remember, we had 52 cards. But since we had one in our hand, the denominator changed to 51. In each of the dice cases, what's going to happen is that our probabilities are going to stay the same. We have the formula for combinations, which we're going to talk about in our example number 4, when the probabilities get a little bit more difficult. But for right now, when we're rolling 3 dice, it's not too bad. We're going to be able to figure out the combinations on our own. So what we have are 3 different dice, and we want 3 ones. That means all 3 dice have 3 ones. First thing that I like to do is, since there are 3 dice, I'm going to put 3 parentheses, a probability for each die. Since I have 3 ones, the probability of getting a 1 would be 1/6. And since I want 3 ones, that means all of them are going to be 1/6. Now, there's a combination. How many different ways can I get 3 ones? Well, there's only one way. All of them have to be ones. So there's only one way that this can happen. So that means that when I multiply 1, 1, 1, 1, I'm going to get 1 out of 6, 6, 6, 216. And that right there gives me my answer. Now for letter B, I want 2 3s. Once again, I'm rolling 3 dice. So if I'm rolling 3 dice, I want 3 probabilities. 2 of them are 3s, and the probability of getting a 3 is 1/6 and 1/6. Then I want one that's not a 3. Remember, we're going back to our complement. If there's 6 possibilities and getting a 3 is one of those, that means the probability of not getting a 3 would be 5 out of 6. Now, this is the combination. We're not going to use the formula. We could kind of think through this. If we have 2 3s, 2 3s would be 3, 3, and not a 3, not a 3, 3, or we would have not a 3, 3, and 3. So there's 3 different ways that this can happen. A combination is all the possibilities. So there's 3 possibilities, so we're multiplying it by 3. 3 times 1 times 1 times 5 gives me 15. 6 times 6 times 6 gives me 216. Remember, we can reduce if we want. In this case, I'm not going to reduce. I'm just going to leave it as it is, so I know that there's 15 possibilities out of all the possibilities, which is 260. Now, if we're looking at letter C, this is talking about no 4s. So once again, I'm rolling 3 dice, so I put 3 probabilities. No 4s means none of them are a 4. So the first one is not a 4. There are 5 that are not 4s out of 6. The second one is not a 4. And the third one is not a 4. So it's 5, 6 times 5, 6 times 5, 6. Now, how many different ways or how many combinations can this happen? Well, no 4s means that the first one is not a 4, the second one is not a 4, and the third one is not a 4. So all of them are not 4s. There's only one way that that can happen. Now, some books use our little marker as a not. Other ones use the C, that means the complement, or not a 4. So you may see me switch to C's or the marks, meaning not. Now, looking at letter C, 1 times 5 times 5 times 5 gives me 125. 6 times 6 times 6 gives me 216. Now, letter D is a little complicated. I'm going to show you 2 different ways of solving this. I'm going to show you the long way first, And then I'm going to show you the easy way. And my hope is that whenever you see it, at least you're going to do the short way. So it says at least 1 5. At least 1 5 means 1 5 plus 2 5s plus 3 5s. Now, 1 5 would be 1 6 times 5 6 times 5 6, because one of them is a 5, the other two are not 5s. There's 3 ways this can happen. 2 5s would be 1 6 1 6 5 6. There's 3 ways that this can happen. And there's 3 5s. That would be 1 6 1 6 1 6. And there's only one way this can happen. So what we're going to do is we're going to take our 75 out of 216. We're going to take our 15 out of 216. And we're going to take our 1 out of 216. And that gives us 91 out of 216. So this is the long way of finding at least. At least we could think of as an inequality. It means greater than or equal to. So that's why it includes 1, it includes 2, and it includes 3. It doesn't include more than 3 because we're only rolling 3 dice. Now let's do the complement. Complement is 1 minus the event not happening. So the event not happening would be no 5s. Now, that would be 1 minus no 5s would be 5 6 times 5 6 times 5 6. Notice this is easier because in the first case we had to find 3 probabilities. In this one we only have to find 1, and we subtract from 1. Remember, the most you can have in a probability is 1. So this is the largest possibility you can have. So that right there would be 1 minus, and since our denominator is 216, it would be 216 over 216 minus 125 over 216. And lo and behold, it's the 91 over 216. Notice that in both of these cases, those answers are the same. Now, with example 4, this is a little bit more difficult because what we have are 4 dice. So that means that there's going to be 4 probabilities. When we're looking at the first one, it tells us that there are 4 4s. So if there are 4 4s, that would be 4 probabilities. 1 6, 1 6, 1 6, and 1 6. How many different ways can this happen? Only one. You get a 4, you get a 4. You get a 4, you get a 4. So that would be our combination. 1 times 1 times 1 times 1 times 1 gives us 1. 6 times 6 times 6 times 6 gives us 1296. Now for letter B, we're going to start using our combination. So we want 1 6. Once again, we're rolling 4 dice. When we roll 4 dice, we have 4 probabilities. 1 6. If there's only one of them, then that means the other ones are the complement. Complement would be 5 6. Now, how many different ways can this happen? 2 different ways you can find it. One is use your calculator. If you remember from Pascal's triangle, what we did was we used our calculator and we put 4 dice, and we want one of them. And when we put it in our calculator, what we get is the answer of 4. So N 4CR is going to be 4. 4 times 1 times 5 times 5 times 5 gives us 500 over 1296. Now, if you want to do this by hand, what we have is the formula up on the top. And the formula up on the top, what we're going to do is we're going to use n factorial. So that would be n is 4, so 4 factorial over r factorial, r being the number 1, and then n minus r. 4 minus 1 is 3, so we go 3 factorial. Now, a factorial means that we multiply all the numbers below it. 4 times 3 times 2 times 1. 1 factorial would just be 1. 3 factorial would be 3, and all the numbers lower than it. 2. We're looking at this, we could cancel. 4 divided by 1 is 4. And that's how we got this 4. I recommend using the calculator, but if you want to do it by hand, you're welcome to use the formula. Now, if we're looking at letter C, no ones. No ones means all of them are complements. 5, 6, 5, 6, 5, 6, and 5, 6. Now, we're going to use 4C0, and when we use that, there's only one possibility. 5 times 5 times 5 times 5 is 625 over 1296. Now, letter D, this is our last one. It says at least. At least means that we want the complement. So the complement would be 1 minus the probability of this not happening. If it wants at least 1, 2, that means 1, 2, 3, and 4, because we're rolling 4 dice. What's not on here is 0. So what we want are 0 2s or no 2s. That means we want the complement, which would be 5, 6, 5, 6, 5, 6, and 5, 6. That would be 1296 over 1296 minus 625 over 1296, and that gives us an answer of 671 over 1296.